Okay, so last time we talked about how to compute complex numbers, right? So let's continue. Last time we did example 10, right? We know that I to the fourth is 1, and therefore if you see the I powers in the denominator, you try to create multiple of 4. And 21, so we can multiply by I to the third to get I to the 24. And I to the multiple of 4 power is just going to be 1. So you remember that, everybody? Mm-hmm. Yeah. So this is what we did last time. And we still have one example that we haven't finished. So let's look at example 9. Yeah, example 9, right. Okay. So here we have the denominator. Okay, so first of all, let's simplify the numerator. Okay, so the numerator 1 times 2 is 2. 1 times negative 4i, negative 4i. 3i times 2, 6i. 3i times negative 4i, yeah, minus 12i squared. Is that okay, everybody? And remember that I squared equals to negative 1. So negative negative become positive 12. Yes. And the denominator is 1 plus 2i. Okay, let's simplify it. The numerator, what's the constant term? 2 plus 12 is, yeah, look at it, combine the like terms. Yeah, 14. And then how many I? Plus or minus? Plus? Plus 2i. Yeah. Plus. Yeah, right. Yeah, sometimes I make mistakes too. Okay, and denominator 1 plus 2i. So far so good, everybody? Okay, and then we're ready to simplify it. Remember, a complex number divided by another complex number, we multiply by what? You mean the conjugate? Yeah, conjugate. So which is what? 1 minus 2i, very good. So 1 minus 2i, we multiply by the numerator and denominator. Okay, so let's look at the numerator. 14 times 1. 14. 14 times negative 2i. Negative 28i. 2i times 1. 2i. 2i times negative 2i. Negative 4i squared, which is 4. Right? The I squared is negative 1. So it flipped the sign to become positive 4. So this is positive 4. And how about our denominator? So, okay, which way do you prefer? Do you prefer to use the formula a plus b times a minus b is a squared minus b squared? Or you prefer just multiply out? Multiply, okay, we can do that. So, yeah, 1 times 1 is 1, right? 1 times negative 2i, negative 2i. And 2i times 1. And then 2i times negative 2i, negative 4i squared. Do you see this middle term always cancel? Yeah, and then this is positive 4. So far, so good, everybody? All right, let's see. Look at the numerator. Combine the like terms. What's the constant term? Yes, 18. And then how many I? Negative 26I. Very good. Oh, how about the denominator? 5. Awesome. So at the end, please separate your complex numbers by the real parts and the imaginary parts. So we have 18 over 5 minus 26 over 5I. So this is the final answer. Okay. So yeah, your homework problem like this one. So you use similar steps. Multiply out the numerator and then multiply by the conjugate of the denominator.
I thought I did that. Like, could you go through it real quick?
Oh, this one?
Yeah.
Oh, okay, sure. Let's see. Oh, you're saying you put the answer, but is that it's wrong? Oh, okay. Let me see. Okay, so we try this problem. Yeah, let's see. Can blank document. Okay. All right, let's try this one. So the numerator, 2 times 4 is 8. 2 times negative 2 minus 4I, right? Oh, by the way, this is your classmate as a homework problem, but you might have a different homework problem because the Mobius generates different numbers. Okay, so yeah, we just think of this is like a practice. So we have what? Is it plus 4I? And then minus 2I squared. Yes. And denominator 1 plus I. Okay. Oh, these cancel. Oh, do you see this guy is positive 2? So we have 10 over 1 plus I. And then we multiply by 1 minus I. The numerator, yeah, let's keep 10 times 1 minus I. Because maybe later on we can cancel. So denominator, 1 times 1. Yeah, 1. And then minus I. And then plus I. And minus I squared, which is positive 1. Yeah, we get 10 times 1 minus I over 2, which is 5 times 1 minus I, which is 5 minus 5I. And you put 5 minus 5I, and it says you're wrong? Huh, interesting. Okay. Yeah, okay. Let me check what happened to it. Okay, thank you. Okay. So far, so good, everybody? Okay, awesome. So, yes. So sometimes if you find a mistake on your homework, let me know. Okay, good. Okay, so this is session 3.1, complex numbers. Any questions? Good. Okay, so we just finished one problem on the 3.1. So don't forget to check out the recording, okay, for the problem you missed. And now let's look at 3.2 quadratic functions. So this is the, okay, quadratic formula. The solution to the quadratic equations ax squared plus bx plus c equals 0. And this is the quadratic formula. Have you learned the quadratic formula before? Okay, yeah, negative b plus or minus square root of b squared minus 4ac over 2a. And example 1. Solve the following equation by factoring in the quadratic formula. Okay, so here I want to just show you this table that I make, okay? Because it is a comparison. Okay. Ooh. Attendance. Thank you. Okay, so I'm going to show you 3 different ways to solve quadratic equations. And the way that you know before is factoring and the quadratic formula. Okay? The way you might not have before is the completing the square. Okay, how many of you need to take calculus 1 and about that? Okay, so then you need to learn this method, completing the square. How many of you just need this course and then you're done with the math? Okay, then you don't need to learn this method, okay? Because in the calculus 1 and other like higher math, you might need the complete square method. But in general, if this is your like final course of math course, then you don't need to know this method. Okay, so let's look at each of them. Factoring. Here are the steps. So first of all, we move all the terms to the left-hand side. Therefore, we want to move the 8 to the left, so we subtract the 8. Okay, everybody? So, and we get 3x squared plus 10x minus 8 equal to 0. So the first step, we move all the terms to the left-hand side. So the right-hand side is 0. And then we can factor the left-hand side. So 3x squared, the factors are 3x and x. Right, everybody? And then the negative 8. Negative 8, the factors are 1 over 8, 2 over 4. But because it's negative, one of the factors is positive, one of the factors is negative. Right? That's why, you try different combinations. You realize if we put negative 2 here and 4 here, we will get negative 2 times x is negative 2x. 3x times 4 is 12x. And when we add them together, we get 10x. So that's why this is how we factor it. Is that okay, everybody? So after we factor it, we can then set each factor equal to 0 and then solve for x. So we set this factor equal to 0 or this factor equal to 0. So a product of different factors equal to 0, we have either each factor equal to 0. So you put the or to connect them, right? Okay, so you have this guy or this guy. And then we solve for x. So subtract 2, we want to move to the other side, so we add 2 on both sides. Then we have 3x equals to 2, both sides divided by 3, we get x equals 2/3. Yes, everybody? Or this guy solve for x, so we subtract 4 on both sides, we get x equals negative 4. So this is how to solve it using factoring. Everybody okay with that? Factoring. By the way, if you need more factoring exercise, you can go to Blackboard and then click Mobius Lessons. And Mobius Lessons, Chapter 1. So I created lesson, Factoring Polynomials. Here you can find more exercise. I think this is like factoring by grouping. Then here, you can practice. Okay, everybody? And then next one. Okay. Comment. We only use this factoring methods when the roots are rational. So rational means we have numerator over denominator, and P and Q are both integers with the denominator is not 0. For example, square root of 2 is irrational. 5/7 is rational. Okay, everybody? So the factoring only works when you have rational roots. Okay, if your roots are irrational or complex numbers, then the factoring does not work. Okay, everybody? So next, let's look at the quadratic formula. Okay, let's save the hard parts later. So quadratic formula, this is the formula. So ax squared plus bx plus c equal to 0. Let's look at this problem. Let's make it more interesting. So this is the problem of our, this is the problem of our example. Now let's change the problem to be 3x squared plus 9x equals to 2. Okay, so change this problem, make it more interesting. Then what we do is also move all the terms to the left hand side. So then we have the standard form. So ax squared plus bx plus c equals 0. This is the form we want. And then a is the coefficient of x squared. B is the coefficient of x. C is the constant term. Is that okay, everybody? Once we figure out A, B, C, then we can plug in the formula. See? Negative B. B is 9, so negative 9 plus or minus square root of B squared, which is 9 squared minus 4. A is 3. C is negative 2. Is that okay, everybody? Yes? Right? Then over 2A. A is 3. Okay? So we plug into this formula, and then we continue to calculate. 9 squared is 81. 3 times 4 is 12, but negative make it positive. 12 times 2 is 24. Is that okay, everybody? Yes? And we keep going. 81 plus 24 is 105. And this is the answer. And this is easy, okay? Talking the project formula is easy. But inside here, you may need to do the calculation and make sure you don't make mistakes. Okay. And let's do last one, complete square. Okay. So how do we do the completing the square? Thank you. So for those of you coming late and didn't sign in, remember to sign in after class. Okay, and did I? Interesting. Okay, this is the third week. Oh, I give you the wrong. Where is the one? Oh, sorry. Choose time again. I give you the old one. Or yeah. Thank you. I'm so sorry. This is the old one. Okay, let me fold this and put it here. So next time I won't get confused. Okay. Okay, so next one, completing the square. So how does it work is, so you have like x squared plus bx, and you want to match some number here so that you get a complete square. And what number to match? Well, you look at the formula, a plus b squared is a squared plus 2ab plus b squared. And a minus b squared is a squared minus 2ab plus b squared. Are you familiar with this formula? Yes? So, who needs to take calculus 1 or apply calculus 1? Now, focus on this one. This is very, very important. Okay, so, first steps. We move the constant term to the right-hand side. So, like this example, we move the constant term to the right-hand side, but the 2 is already on the right-hand side. So, that's good. And then, second step. Factor out the coefficient of x squared. So here, coefficient of x squared is 3. We want to factor out the 3. Okay? So when we factor out the 3, do you see the 9x become 3x? Because 9 is 3 times 3. If you factor out the 3, then we have 3x left. Is that okay, everybody? And then, okay, we have this x squared and then plus bx. How do we want to match? Well, compare. So the x is like the a, but here the 2ab, but we only have the b. So that's why this term, we want to divide it by 2. And we divide it by 2. And then, because this is the b, the b phrase is now like b over 2. I know the formula is not so Good. Let me call it different names. So let me call m plus n squared is m squared plus 2mn plus n squared. Let me call a different name because use of b here and there is a little bit confusing. Okay, so if we call this, are you okay with this formula? We just call it different names, but this is still true, right? Now we can compare. Our goal is to add something here so that this guy can be recognized a complete square. So now let's see. Look at the first term, x and m, right? So look at the first term, m squared and x squared. So we get the m equals x by comparing it. And then look at the middle term. The middle term, we have 2mn equals bx. Do you agree? But the x is m. And then you can both sides divided by m, you get the 2n equals b. Do you agree? So the n equals b over 2. Okay? Therefore, here you want to match the n squared. That means you want to add the b over 2 squared. So then this is a complete square of m plus n. Now my m is x, my n is b over 2. Is that okay, everybody? So we're comparing term by term. Okay, the x squared comparing with m squared, we get m equals x. The middle term, the 2mn and the bx, set them equal, and because we know x is m, so we can plug it in, and we get 2n equals b. So n equals b over 2. So that's why this guy, yeah, we get x plus b over 2 squared is x squared plus bx plus b over 2 squared. Okay, so therefore why we look at what's the coefficient of x and then use it to divide it by 2. Then we want to add the b over 2 squared here. And be careful, you also need to add this to the right hand side. So that's why here, the b is like 3. And then you ask, okay, this guy divided by 2. So b over 2 is 3 halves. Then we want to add the 3 halves square here. 3 halves square is 9 over 4. So we want to add the 9 over 4 here. But what's the effect? Let's do. The effect is, well, you're adding this, but you need to multiply by 3. So the effect is like you're adding 3 times 9 over 4 on both sides. Is that okay, everybody? And then, oh, this is the complete square of x plus b over 2, which is 3 halves. So this is complete square of x plus 3 halves. And on the right hand side, we have 2 plus 3 times 9 is 27 over 4. And then, oh, okay, what is that? Well, the common denominator is 4. 2 is like 8 over 4. And then 8 plus 27 is 35 over 4. Okay, and then we keep going. Okay, so 35, yes, 35 over 4, both sides divided by 3. Now we get 35 over 12. Now this is a complete square. We can square root both sides. And when we square root both sides, the right hand side we get plus or minus square roots. Is that okay, everybody? And then, okay, what's plus or minus square root of that? You know 12 is 4 times 3, okay? If you want to rationalize the denominator, you want to multiply by 3, okay? So multiply by 3 and divide it by 3, then the numerator is square root of 105. The denominator, square root of 36, is 6, okay? Now, we both sides subtract 3 over 2. Therefore, x is negative 3 over 2 plus or minus square root of 105 over 6. And you will see this is the same answer when you use a quadratic formula. You get the same answer. So this is the method of completing square. Okay? And in general, this is hard, but it works in like other applications. For example, you can use it to find the vertex of parabola. You can use it to find the center of the circle. And it's also useful in calculus 2 and higher math courses. Okay? So, yeah, it depends on whether you need to take like the calculus and above. So, and then, yes, so this is the complete square methods. Okay. If you like have questions, feel free to come to ask me. Okay. All right. But in our course, when I ask you some problem, I won't limit the methods. You can use whatever method you like. Okay. All right. So let's continue. Okay. Okay, quadratic function. So quadratic function is a function that can be written in the form of ax squared plus bx plus c, where a, b, c are real numbers and the a is non-zero. Because if a is 0, this is a linear function. It's not a quadratic function. Okay, and then the graph of quadratic function is a special type of U-shaped curve we call parabola. Wait, let me find my color. Okay, parabola. And all parabola are symmetric with respect to a line. It's called the axis of symmetry. Okay. The points where the axis intersect the parabola is called the vertex of the parabola. Okay, and look at this picture. So this is a parabola. It looks like a U shape, and this is the axis of symmetry. Okay, it's the parabola is symmetric with respect to this line. So this is the axis of symmetry, and this line intersects the parabola at a point. This is the vertex. So in this case, this is the vertex. So far, so good, everybody? Okay, and how the value of A affects the parabola? So we know y equals ax squared plus bx plus c. Okay, if A is positive, then our parabola opens up. Okay? If A is negative, then our parabola opens down. Okay, and how about the c? The c will give us the y-intercept. Okay, so we call A is the leading coefficient. And we call C is the constant term. The leading coefficient decides whether the parabola opens up or down. The constant term gives us the y-intercept. Okay, the y-intercept is 0, c. Is that okay? Because when you plug in x is 0, see? When x is 0, this term is 0. This term is 0, so y equals to c. So this is the y-intercept of the parabola. So far, so good. Everybody? Okay, let's keep going. All right. So when a is greater than 1, then the graph of y equals a times f of x is a vertical stretch of the graph y equals f of x. Do you remember like transformations when we multiply by a number? Then if a is greater than 1, we have a vertical stretch. If a is between 0 and 1, we have a vertical compress. Do you remember that from session 1.5? Yes. Okay, so that's why, we call from the session 1.5, okay, we have, for this, right, x plus or minus c, what's the transformation? Shift left or right. And when you shift left, is it plus or minus? Yes. Plus is left. Plus is less. Right is minus, right? Yes. Okay. And how about this guy? Shift up or down, right? Up is plus, down is minus, right? And how about minus in front of x? Refraction over the y-axis. How about the minus sign in front of f of x? Refraction over the x-axis. And yeah, the one we just talked about. So y equals c times f of x. This is vertical stretch. Yes, everybody? Okay, so that means, how would that change? The x is the same, but you multiply the y value by c. Yes, everybody, for all the key points. And last time we also learned f of c times x. What is that? Instead of vertical, you have, yeah, very good, horizontal, compress. And how would the point change? So will that change your y value? No, but your x value divided by c. That's the difference. Your x value divided by c. You don't multiply by c. That's why it's compressed, not stretched. Is that okay, everybody? Yes. Do you remember those? Right? Mm-hmm. Okay. Now example 2. Sketch the graph of each quadratic function using the transformations from the parent function y equals x squared. Okay, let's see. Y equals x squared. So we start with the parent function. Okay. So y equals x squared. Well, you want to write down the key points. Do you remember the math move? Okay, move your hands. Line, x. Graph x squared, x cubed. And square roots, cube roots. Right? And then reciprocal root. Alright? Right? Like that, right? And then absolute value. Yes. Okay, good. Yay! Do exercise. And then, okay, so the key points are the 0, 0 and 1, 1, right? What's 2 squared? 4. Yes. Okay. Negative 1, 1, right? Negative 2, 4. So this is the parabola. So far, so good, everybody? Yes? Okay. Keep going. Okay, let me draw it better. Okay. All right. So we follow the order of transformations. Could you tell me what was the first step? You said what? Yeah, all right. Yes. So and then we look at, oh, do you have like L subtract the number from the x? Yes, we have. So we have x plus 4 squared. Shift left or right? Yeah. Shift left 4 units. Okay. So in the exam, you need to write down the formula, the transformation, and the graph in each step. So shift left 4 units. So then, you see, the 0, 0 become 4, 0, right? And then this is gonna be what? 5, 1. Yes. And this is 3, 1. Yes. And this is gonna be also 2, 4, right? And this is 6, 4. So we connect them. Okay. Silly, yes, yes, yes. Sorry. Okay. Right. You see, I make mistakes too. Okay. All right. So, okay. Then I need more space from the left. So shift to the left. Oh. Okay. So now this is right here. Okay, -4. Okay, -4. And then -3, 1, -5, 1. -2, 4, right? And -6, 4. Okay. Yes. We shift left 4 units. Okay. And then what's the next step? We check. So first step, shift left or right. Second step, we flip over X, Y. Yes. Oh, do we have refraction over the Y axis? Do you see a minus sign in front of the X? No. This minus sign is in front of everything, right? So that's therefore we have what? Refraction over the x-axis. Very good. So y equals negative x plus 4 squared. And this is reflects over the x-axis. Okay. X-axis. That means we want to flip it down, right? So this point, what happened? The -4, 0 stays here, right? So -4, 0 stays here. Then how about this guy? We flip down, right? So -5, we flip down. We got -5, -1, -3. We also flip down. And then -2, we flip it down there. So this is -4. And also there, here we have -4. And we connect them. Is that okay, everybody? And next. Okay. What's the next step? Do we have horizontal compress? No. We have vertical stretch, right? So y equals -2 x plus 4 squared. So vertical stretch by a factor of what? Yes. Okay. And now let's see. Here, the x value is the same, right? But the y value is going to be multiplied by 2. Oh, so the minus 1 is now become -2, right? But the x value is the same, right, everybody? Okay, so therefore we have, okay, -2 right here. And here, -2 right here. Okay, so this is go down. And the -4 become what? -8. Yes, everybody? So, which is so down, okay? 2, 6, sorry. 2, 4, 6, and 8. So, which is right here. Okay, and then we go down. Okay. And then finally, what? y equals -2 x plus 4 squared plus 3. This is what? Shift up or down? Up. 3 units. Okay. We have shift up. So 1, 2, 3, 4. 1, 2, 3. Okay. And this shift up 3 units, you get 1, right? And this shift up 3 units, we get 1. How about the -8? You shift up 3 units, you get what? -5. So 1, 2, 3, 4, 5, -5. And which is right here. Okay, we connect them. So in your exam or your quiz, please label the important points. Okay, you don't need to label every point, but the important points, label it. Because help me, I don't want to count for each student. We have 34 students. If I count the part, it will take a lot of time to do. So please label the important points. Okay, everybody? Yes. So this is how we transform from the parent function y equals x squared to this new one. Okay. And just by looking at this graph, can you tell me what is the vertex? -4, 3. Can you tell me what's the axis of symmetry? Yeah, x equals to -4. It is a line. Okay? So don't tell me just -4. It's a line. It's not a number. Okay, everybody? So if you give me a line, a vertical line, x equals the number. It's an equation. Okay, not just a number. It's an equation. It's a line. Okay, very good. Okay, so let's keep going. Okay, standard form of a quadratic equation. Okay, so this is the general form. Okay, ax squared plus bx plus c. And the standard form, this is the standard form. Okay, and how do we convert from the general form to the standard form? What's good thing about the standard form? So if we have this standard form, then the graph is a parabola whose axis is the vertical line. So the vertical line would be x equals to h. This is the axis of symmetry. And the vertex is, okay, you think about when is the x is when the y is the smallest. Okay, so if we draw the picture, okay, let's say the picture looks like this. Okay, and let's say a is positive, then our parabola opens up. Okay, and you think about, okay, what is the smallest possible y value? Well, you know x minus h squared. But this guy is always greater or equal to 0. The smallest when this guy equals to 0. So when this guy equals to 0, x equals to h. Right, everybody? So that's why, our lowest point is when x is h. Okay, when x is h, and then when you plug in x is h, do you see h minus h is 0? This term is 0. So we get f of h is k. So this standard form is very good because we can tell the vertex right away. We can also tell the axis of the symmetry right away. Okay, everybody? Yeah, if A is positive, then the parabola opens upward, and then if A is negative, then the parabola opens downward. Okay, so it tells a lot of information. We can sketch the picture of it. But how do we convert from the general form to the standard form? Okay, I'm gonna show you the proof. Okay, so here we need the okay, let's see. Let's compare the coefficients. Okay, look at this guy. So let's multiply it out. So we have x minus h squared is x squared minus 2xh plus h squared. Is that okay, everybody? Yes, we multiply it out. This is a complete square. X minus h squared is x squared minus 2xh plus h squared, right? Okay. Excuse me. Thank you. And then let's distribute it. So we have a x squared, right? And then minus 2a xh plus ah squared plus k. Yes, everybody? We distribute the a. Okay? Now, let's see. Compare. Now, let's rewrite it. So this is a x squared minus 2ah x. So I want to put the x at the end. So 2ah is like the coefficient of x. And then plus ah squared plus k. Now we're ready. Compare the like terms. Do you see the first term, ax squared is ax squared, right? And then the second term. Look at this. Has the x in here, and the coefficient of x is b, but the coefficient of x here is negative 2ah, right? So by comparing, okay, so we compare, we get b equals negative 2ah. Yes? This is the coefficient of x. That's the b. So b is negative 2ah. Is that okay, everybody? And then how about the constant term? Wow, the constant term is c. So c equals ah squared plus k. Yes? So from this, we can solve for h. H is both sides divided by negative 2a. We get h is b over negative 2a. And we solve for k. K is c minus ah squared. Okay? Therefore, we have the formula h equals negative b over 2a. And what's k? Well, k is this, but it's also equals to f of h. Because when you plug in h in here, this guy, h minus h, is 0. Right? So you get k equals f of h. So k also equals to f of h. And this is a formula for h and k. So from now on, because I have shown you why we get to these formulas, then you don't need to do the proof. You just use the formula. So this is how we convert from the journal form to the standard form. Is that clear, everybody? Any questions so far? Oh, good. Okay. All right, let's do it. Okay. Yes. And then, all right, yes. So the vertex h equals negative b over 2a, and the k is f of h. This is the vertex. That's why if a is positive, the parabola opens up, then we have a minimum here. Do you see we have a minimum here? The minimum is at x equals to this vertex, which is h, right? Negative b over 2a. And then this is the minimum value f of the h. Okay? If a is negative, the parabola opens downward, then this is the maximum. Yep, the vertex is the maximum. That's why the vertex is very important. Okay, and the domain for any quadratic functions is all real numbers. The range Well, the range, it depends on the A, whether it's positive or negative. If A is positive, the range is from K to infinity, including the K, right? And if A is negative, then the range is from minus infinity up to K, including the K. Is that okay, everybody? Mm-hmm. Yeah, so we know a lot of information from the standard form. Okay, example 3. Sketch the graph of f of x equals to x squared plus 8x plus 7. Identify the vertex and the axis of parabola. Find the x-intercept. Okay, so this problem, we look at, so a is the coefficient of x squared. B is the coefficient of x. C is the constant term. And then you just plug into your formula. See? Your formula, h equals negative b over 2a. And then our k is f of h. So far, so good, everybody? Mm-hmm. Okay. A way help you to memorize this is, do you remember the quadratic formula? Okay, the quadratic formula is negative b plus or minus b squared minus 4ac over 2a, right? And then you realize, oh, my h is just this part, negative b over 2a. This is the h. Okay, everybody? So if you forget of h, write out the quadratic formula. Then this negative b over 2a is the h. So far, so good, everybody? Okay, now we plug in it. We have negative b, what's b? 8. Over 2a, what's a? 2. Oh, what is this? Negative 2, right? Okay, good. So my k is f of h, h is negative 2. So that means you plug into the function, replace x by negative 2. So you don't need to remember this 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 crazy formula. You just remember f of h. Okay, this is easier to remember. So we plug in, whenever we see x, we replace x by negative 2. Okay, so 8 times x is negative 2. And then plus 7. So far, so good, everybody? Mm-hmm. Okay, and then we got 2 times negative 2 squared equals 4. And then, oh, what's 2 times 8? It's 16. Oh. 2 times 4 is 8. 8 minus 16. Negative 8 plus 7. Negative 1. Very good. Oh. So we get our vertex. So vertex, h is negative 2. K is negative 1. And what's the axis of symmetry? X equals to negative 2, right? And how about our standard form? So standard form is y equals a. A is, okay, remember standard form, a times x minus h squared plus k. A is 2. Okay, what is negative h? Negative 2 is 2. Yes. So plus 2 square, and k is negative 1. So this is the standard form, okay? Now we can sketch it. So we have the vertex is, oh, okay, let me make it down a little bit. -2 and -1, okay? And then we know the parabola opens up, so looks like this. Oh, but we also need to find the x-intercept. So how do we find the x-intercept? So 0, set y equal to 0. Okay, so x-intercept, we set the y equal to 0. Okay, so we got 2x squared plus ax plus 7 equal to 0. Right, everybody? In this problem, can we factor it? No, right? Yes, no, right. So let's use quadratic formula. So x equals -b. So negative, what's b? 8 plus or minus b squared. 8 squared is 64 minus 2a. A is 2. C 7 over minus, oh yeah. See, I made a mistake again. So over 2a. 2a, a is 2. Okay, good. Alright, so -4, 8 plus or minus. Let's see. So 4 times 2 is 8 times 7. 56, right? 64 minus 56 is 8. Oh, square root of 8 over 4. Okay, do you know square root of 8 is 2 and root 2? So we can cancel the 2. So we get -4. So divide numerator and denominator by 2. We get -4 plus or minus square root of 2 over 2. Is that okay, everybody? So that's the x-intercept, okay? And yeah, this is not 1. This is not -1. It's this point is the -4 minus square root of 2 over 2. This point is the -4 plus square root of 2 over 2. Okay, so we have two x-intercept. -4 plus square root of 2 over 2 comma 0, and -4 minus square root of 2 over 2 and comma 0. So these are the x-intercepts. So far, so good, everybody? Yes? Awesome. Okay, let's keep going. Okay, example 4. Write the standard form of the equation of the parabola whose vertex is 1, 2, and it passes through the point 3, -6. Okay, standard form. Yeah, you gotta remember the standard form. That is a times. Yes, very good. And now we know the vertex is 1 and 2. Which one is h? 1 is h, 2 is the k, right? So we plug in. So y equals a, the h is 1, the k is 2. Is that okay, everybody? We start with the standard form. And then the vertex is h comma k. So h is 1, k is 2. Now we plug into the standard form. Right, everybody? And so good, we know h and k. We also need to know a. And there's one information we haven't used. What's that? it passed through the points, right? So it passes through the point 3 minus 6. So we plug in y is negative 6. And the x's, see, this is the x. This is the y. We plug in it. X is 3. Is that okay, everybody? We plug in the x is 3 and the y is negative 6. And we want to solve for a. Okay, let's see. What's 3 minus 1? 2. 2 squared. 2 squared is 4. Okay, what do we do? Subtract 2. Minus 6 minus 2 is negative 8, right? Oh, what's 8? Negative 2. Nice. So the standard form, y equals a is negative 2, x minus 1 squared plus 2. Okay, how do we draw it? So 1, vertex 1, comma 2. This is the vertex. And A is negative, so parabola opens up or down? Down. Okay, so we know it looks like this. So far, so good, everybody? Oh, but by the way, my picture is not so good. I don't mean to say it has through the origin, but if you want to know what is the x-intercept, well then, if you want to find the x-intercept, you can set this equal to 0 and solve for x. Is that okay, everybody? Yeah. Questions? Where did the square go? Oh, here? Yeah. 3 minus 1 is 2. 2 squared is 4. Yeah. All right. Any questions about this problem? Are we all good? Yes? Okay, then let's continue on Monday. Have a good weekend. And don't forget, what? Today we have a quiz. So go to Blackboard and do your quiz. And please work on your homework as well. So, yeah, try to finish your homework up to 3.1, okay? So we already completed the complex numbers. Bye!
I mean, here's the, I can express it as you said.
Ah.
This is your one.